My name is Janusz and I will talk about benchmark superodometry to HD mapping. So let's take a look how to perform this experiment. So we have superOdom converter to HD mapping. Hint, we go to our favorite branch and follow instructions. So first, in step 1 we have to prepare data. So we go here. This is Kazam, so I will open new. Okay, and I am copying this conversion to HD mapping. So now we're converting data from ROS1 to HD mapping, and after that we will convert from HD mapping to ROS1. I think we changed topics or something. My colleagues did that. It is necessary, so please be advised to study it by your own. For me, it is more important that we have end-to-end solution. Just copy paste and enjoy this experiment. If you find some issues, please let me know. Okay, done. So another conversion. So if we go to our website, then you will see that it is very easy to navigate through all of information. The idea is that all information is in one place. So let's take a look what we are doing now. Superodometry, so you can find from where it was, how to cite it. So we provide all information how to cite things, and also you can find all information about algorithm. For example, here in this link you have everything about the algorithm, and it looks very promising, and I will show you how it works. It was tested, I think, by many people with any robots. So and it looks very good. But we will back to this website. Okay, so we just copy here. So what we have, step 2, we prepare our Docker, so we don't have to make this folder. We have already. Give me a second. Okay, so let's go one by one. So we clone our repository. We check out to our favorite branch, then we put all submodules, and then we build the Docker. Third step, data conversion. So we have to convert from ROS1 to ROS2, so let's do that. So we run the Docker, we go to the data, so you can see most, let's say, steps are about data conversion. Running algorithm is quite easy because you have to run the Docker, but data conversion makes it quite tricky. Even because we are facing the transition from ROS1 to ROS2, so you have to be aware that life is not easy in that sense that you have to take care about topics, data, and so on and so on. We are trying to solve this by giving some Dockers and giving some examples that you can easily follow, but let's hope everything works. So back to information. So let's see what data set we have. So it is bunker dataset, so we will see on the left after a moment, and I will talk about this dataset. So our colleagues from Royal Military Academy, Charles and colleagues, they already, I can see, put citing. So please don't forget to cite them if you use this dataset. I will back to this after a moment because we have already. Oh, I lost my instruction, so let's back to our instruction. The good thing is that everything is in one place and it's very easy to navigate, so it is very easy to find instruction again. So we were talking about superodometry. So we jump to our favorite branch again, and we had a fourth step, so we have to simply exit from this Docker, and the last step is running experiment, and then we can observe what is going on. Okay, so we change accesses rights, and then we run experiment, and I hope my instruction is proper. So if I make a Ctrl B W up, then we can see everything. So, oh, something wrong, but I don't know. Let's observe the data, and let's observe this one, experiment, and observe on the left side data set. So this is our data set. Data set is collected by this fantastic device. Our colleague designed it to create data sets, and this is with 3D LiDAR, active, passive, and time-of-flight cameras, and obviously multiple IMUs. It is crazy good stuff. I am very happy to work with data from it. I wish I have something like this in my lab. Maybe in future we will see how the future will look like. So, shortly speaking, we have something like, is it like this, or I think so. This is like this. So we are already here. So we are going, and I am very curious about the result, because it is this algorithm. It can be. You can see that authors publish something in 2021. Okay, in a very nice conference, in IROS conference, and after that they spend some time in 2025. They publish something in ICRA, and this is, it looks like a very major work. So let's hope it will give us some very nice insights, very nice results. Or you can see here, wow, it can work in long corridors. Oh, wow, it's very impressive. Okay, so we are almost in the middle of the experiment. We are almost in the middle of experiment, and it looks very promising. So we have still plenty of time. I can give you some insights how to work with our project. So basically speaking, once we go there, then the idea is that we provide end-to-end mobile mapping solution, and our goal is to find, develop, discover best end-to-end mobile mapping framework. So what we do, we are trying to collect all open source algorithms, test them, and choose the most ready one for the deployment in real applications. And you can see that we have already, I think, more than 20. I think, yes, we have more than 20 algorithms, And the idea is that we use this experiment from our colleagues, this bunker dataset, as a starting point, and we provide movies how to do this experiment for all algorithms. Today my job is to make 3 movies, so I am doing now this one superodometry. I have to make another 2 after this, so let's hope everything will be okay. Okay, we're going back with our LiDAR odometry. You can see here. Let's make closer, and you can see that it works very, very good. You can see that the estimation of your position and trajectory is very promising. So it looks like very robust algorithm. So let's wait a moment. I think 20% of the data set still has to be calculated, and then we will export data and visualize in our tool, and obviously in Cloud Compare. So we are approaching last narrow passage. You can see plenty of narrow passages like this. It's challenging for some algorithms. So transition from big room to small room, and order from smaller room to big one. You have all challenges you need to test your system. You can see even some pipes on the ceiling. Oh, we back to the same room, so everything is fine. We back to the same place. Mission succeeded. So now we should expect another things, a lot of red color. I hope it is not so significant problem. Now the system is exporting data to our HDMapping format. In that sense, this format is used that everything will be compared in the same frame and the same in one system, one visualization tool. So you can jump from ROS or ROS2 directly to the some offline tools, and that will help you to visualize and to make some quantitative and qualitative analysis. Okay, so it will be in output HDMapping ODOM, so let's find it. So we have benchmark, and we have data output superOdom. This is this one. Okay, so let's save it. Let's go to our framework. In our build we have multi-view TLS registration, so we have to open this session. Okay, this is our session recorded, and now we can easy to export everything. If you would like to see more points, you can increase this. And now let's export to all Mars scans as a global scan. So this is, where is it? superOdom, all LiDAR odometry LAS. And once we have this exported, then we can open. Where is it? Did I export it correctly? Maybe I put it here. No. Okay, let's back to this. Let's export again. So save all max scans as global scan. Data superOdom all LiDAR odometry.las. Okay. superOdom. Oh, now we have. So let's open Cloud Compare. Let's open the result, and this is the result that we have from our superodometry. So you can see and you can enjoy your result. So this is the result, and it looks very promising. I am very impressed of this algorithm. So let's hope authors will continue the research. Thank you for watching. See you next movie. Ciao.